Hey everyone, Mr. Newman here. This is just going to be a quick review video for 4.2 and 4.3, both dealing with arithmetic sequences. So let's get started. First of all, notice that these pages, there are a handful of review problems in the textbook that would be great to do once we get to class, and we'll do those. This first problem, we actually didn't do any of this type, but this is something that you can do because notice it gives us the $4 per month, and it says a startup fee of $8, but it goes ahead and gives us the explicit rule, and you guys have been using explicit rules, so you'll do just fine on this. It says construct a graph of the first 4 terms of the sequence. That's what we have to do, but before we can make a graph, we need to figure out the points in the graph, and to do that, I'm going to use a table. So my headers are n, the step number, and f of n, the function. Let's do 1, 2, 3, and 4. Those are the first 4 terms of the sequence, and to find the first term, f of 1, we plug that into our f of n. And instead of n, I put 1, and we get 4 times 1 plus 8, which is 12. So at point 1, that's going to be 12. The second one is going to be 16, because we plug in 2 into the function. And the third, I'm not going to write it out, but you plug in 3 into that function, you get 20. And you plug in 4, you get 24. So my points are 1, 12, 2, 16, 3, 20, and 4, 24. Next, we need to make axes that are scaled well and labeled. So let me show you how to do that. Well, you notice the input is n. That's because it says $4 a month. That's going to be, n is the number of months. So n of 1 means 1 month. F of n, it doesn't say in there, but it does say how much it costs is $4 per month, and it costs a startup fee of $8. So the rule actually gives us the total cost. And when you do this, we need to scale on the y-axis by more than just ones because we won't get all the way up to 24. I like scaling by 4s because, or skipping by 4s because that's going to include all the numbers in my y part of the table there. So I'm going to go 4, 8, 12, 16, all the way up. And you notice it includes all of those, which is great. On the x, we can just go by 1s because it's 1, 2, 3, and 4. And now I'm going to plot the points. So 1, 12. 2, 16, 3, 20, and 4, 24. Before we leave this problem, because we just finished it, I do want to point out a few things. First of all, notice that this does make a line, but we cannot connect the dots because this is discrete. Those points should be separate. For one thing, it's $4 a month, so I'm assuming you pay for the whole month, like most subscription fees. And so we're not going to talk about, well, at a half a month, you're going to pay $2. No, we're just going to pay each month. And it doesn't matter if you're at 2.5 months, that's not a part of the domain. It's just if you're in 2 months or 3 months or 4 months. It does make a line, though, because it's linear and they go in a straight line. And in fact, it's increasing linear because it's going up. And it's an arithmetic sequence because, for one thing, it's in the arithmetic section of the textbook, but more importantly, it makes a straight line, so it's arithmetic. So I don't know if you connected those two until now, but anytime you have an arithmetic sequence, if you graph that, it should make a straight line. And any line can be changed into an arithmetic sequence if you just look at x equals 1, x equals 2, x equals 3, and x equals 4, and so on, all the whole numbers. So just some comments about that. Let's go and try the next problem now. Oh, by the way, linear and arithmetic, that means the same thing in this case. Write a recursive rule and an explicit rule for this sequence. So first of all, what we need to do is we need to make a table, n and f of n. This will be a sideways table instead because that's what I have space for. The first step is 20, then the second is 14, then 8, and then 2. So that's going to be my n because n represents the step. Step 1 is going to be 20, step 2 is 14, 3 is 8, and 4 is 2. Now, to make a recursive rule, remember that you need f of 1 and you need f of n equals f of n minus 1 plus whatever the common difference is, whatever that change is. So you need both of those to write a recursive rule. So let's go and do that. Well, the f of 1, that's the first input. And what's the output of that is 20. So f of 1 equals 20. That's where our sequence starts. F of n equals f of n. Notice I put in purple all the parts that stay the same from time to time. And that blue 20 is the thing that changes when you're writing a new recursive rule. The d is another part that changes, and that's the common difference. So to calculate that, we got to figure out how much do we go down by to go from 20 to 14. Well, we go down by 6. So minus 6, minus 6, minus 6. So it's going to be f of n, which is in English this means whatever step you want to find, look at the previous step, f of n minus 1, and subtract 6 from that previous step. So we do that, and there's our recursive rule. For the explicit rule, we use this formula. Notice the parts that stay the same. We're going to use f of n, that stays the same. F of 1, we already know is 20. That's the first spot. The difference we already calculated is negative 6, so minus 6. And then times n minus 1 stays the same. So what's going on here? Well, notice the blues and the greens, how they match up, and how the parts you change are always those two, the starting value and the changing value, the common difference. And the parts that stay the same are the ones in purple. So that you're always writing n minus 1 when you're writing this rule. Now, you can simplify that, but I'm not going to make you do that because right now we are not at that stage yet. So I've got my rules, and there's my recursive rule is the first one, and my explicit rule is the second one. Let's do this last problem here. Construct an explicit rule in function notation for the arithmetic sequence in the graph, and use it to solve the problem. Well, to do that, the first thing we need to do is I need to make a table, because I need to figure out what is that common rate of change, and the best way to do that is make a table. So n is the number of days, and f of x is the total sale in thousands of dollars. So that is going to come up to help us when we answer the question at the end. So remember that thousands of dollars. So when n is 1, we know that that point is 1, 15, so f of n is 15. Then, see that point right there? Then 2 is 20 because of that point right there. Step 3 is going to be 25, and step 4 is 30, and so on. And I don't need to write them all down here. I just need to write enough that I get an idea of the rule. So remember, to find the explicit rule, here's our formula. This f of n and the n minus 1 stays the same. My f of 1, my first entry is right there, 15. So I put 15 right there. And then d, the difference, that's plus 5 every time. So I'm going to put plus 5 times n minus 1. So we've got our rule. And then it says the question is, what are the total predicted sales on day 10? Well, we know that days, there's our thing. Day 10, days is n, because we said number of days at the bottom, and it says for n days, and it also says day 10 at the bottom there. So we're going to say, all right, when n equals 10, what is the output? In other words, what is f of 10? Well, let's plug this into our fancy-dancy formula we found. So we found 15 plus 5 times n minus 1, but I'm plugging in 10 for n, so instead of n, I'm going to write 10. Now I just need to follow order of operations, GMDOS, and we do grouping first, then we do multiplication before addition, and then we add them, and we get f of 10 equals 60. But we have to be careful, because to answer the question, we need to read our graph. What are the total predicted sales on day 10? Well, total sales is in thousands of dollars. So 60 would mean $60,000 is the predicted sales for day 10. All right, thank you for watching.